Okay. So in autoionization of water, we said that water is going to work like an acid and like a base. One water molecule like an acid, another water molecule like a base, and they will transfer. One is going to give proton, other one is going to gain proton, and they will give you H3O plus and OH minus. These are pure liquid, but this one is aqueous. So what is Kw here? What is Kw? It is the Kw, the ionic product of water, or dissociation constant for water, is the concentration of hydronium ions times concentration of OH minus. And what was the value at 25 degrees Celsius? 1.0 times 10 raised to power minus 14. And no units because it's equilibrium constant. But this value is constant at 25 degrees Celsius. Now from here, from this ionic product of water, remember the name ionic product of water. We are going to decide whether the solution is acidic or basic. See here, if the concentration of hydronium ions are equal to the concentration of OH minus, you are going to call it as neutral. Neutral. These two are equal. But if in a solution, concentration of hydronium ions are hydronium, H plus hydronium acidic, greater than concentration of OH minus, then solution is, yes, solution is in that case. Yes, please. Solution is hydronium is greater, hydronium. Yes, it is acidic. If the concentration of OH minus is greater than concentration of hydronium, then the solution is basic. So you can identify whether the given solution is acidic or basic by comparing the hydroniums, OH minus, which one is more. If they are hydronium means, what is the meaning of hydronium? Hydronium means acidic. Hydronium, which is what is the other name of hydronium, children? H plus, right? And this is hydroxide, means basic. If this is more, basic. If this is more, acidic. If these two are equal, then neutral, right? Okay. Now I'm giving you one condition here. The concentration of hydronium ions is a question. I'm asking a question. I hope my audio is clear. The concentration of hydronium ion is 1.0 times 10 raised to power minus 7. Now this is concentration, children, concentration. So it has a unit of, what is the unit of this number? Unit, Azuni. Lisa, what is the unit of concentration? Aslisha, try to answer. Yes, molar or moles per liter. Yes, molar. Good. That's the unit. Okay. Now, if the concentration of hydronium is this, can you tell me what is the concentration of OH minus? You already know the product is this. You will use this value to calculate the other mathematically, right? So it is Kw. I'm using this equation, children, this one. Kw over concentration of hydronium. Plug in this value and you will get your answer. Yes, good, Azuni and Aditi. It is 1.0 times 10 raised to power minus 7 molar. So what kind of solution is this? This one, solution 1. Is it acidic, basic or neutral? Solution 1. It is neutral. Yes. Okay, now I'm giving you solution 2. Solution 2, hydronium ions are 1.0 times 10 raised to power minus 2 molar. Can you work out the OH minus concentration? Yes, please. Work out the concentration of OH minus. You can use this equation, this one, right? This one. Hydronium is given, so you can convert the equation in this format. Plug in the value, and everybody is giving me the value as 1.0 times 10 raised to power minus 12. And you people are giving me, who is giving me without unit? Aditi, you are giving me without unit. Only Aditi and Azuni and Lisa are answering. What about rest of you? Anil cannot answer because he is in the flight. Aslesha, you're not answering? Aslesha, you're there? Can you type yes or no? Start answering, dear. Okay, now tell me, which one is more, the hydronium or OH minus? The hydronium is more, so it means the solution is acidic or basic. This solution is acidic or basic? It is acidic. Can you see that how I'm deciding by comparing the hydronium and hydroxide with the ionic product of water, and from there we are deciding is it going to be acidic or basic. Okay, now one more example. This time the concentration of OH minus is given to us as 1.0 times 10 raised to power minus 6 molar. Can you work out the concentration of hydronium? Use the same equation. Very good, Azuni. Very fast. 1.0 times 10 raised to power minus 8 molar. Now tell me, is this solution acidic or basic? Good, Aslisha. Is this acidic or basic? This solution is, Azuni is saying basic, Lisa is saying acidic. Which one is more? Check the numbers. Which one is more? This is minus 6. This is minus 8. Which number is more? This one. So it is basic because OH minus concentration is more than hydronium ion concentration. So you can see that the pH, the acidic nature or the basic nature of the solution can be decided by the ionic product of water value. This value is at 25 degrees Celsius. You change the temperature, value changes. So they specify at a particular temperature. Now, rather than working with these exponential numbers, minus 6, minus 8, you know that I told you that pH is very important thing in our common life, in our normal life also. Common people, they also are dealing with this pH. But if you start telling them numbers like exponential like this, then many people, they don't have any mathematical background. So they will start getting confused. So scientists have decided a scale, a simple scale, and we call it as pH scale. pH. And this pH or pOH, this scale is based on this number. So I'll explain you the scale, the pH scale. Now we are going to do the pH scale. Before we go for that pH scale, can we do this question very fast? You have to identify the solution as neutral, acidic, or basic. Yes, A. Very good. A is neutral. B. B. B is basic because this concentration is very low. Yes, it's basic. Very good. Basic. C. Very good. C is acidic. H plus ions concentrations are very high. D, and D is also acidic. No error. Perfect. Anyone confused about it? Any confusion? No? Okay. Now let's move to the pH scale. As I said, that we need to have a simple scale to classify the solutions as acid and bases, to compare the acidity. Some solutions are very strong acid, they are not good for us. Some solutions are mild acidic. Milk is also acidic. So there are so many things. You can see here the examples. Baking soda we are using in cakes, sea water, blood, pure water. See up to here. Below this, whatever you are eating, milk, black coffee, vinegar, lemon juice, stomach acid, battery acid. Battery acid, the battery which we are using in cars, you are going to learn about it in Unit 9. It is based on H2SO4 and PbSO4. If you remember, last time I told you H2SO4 as the king of the acids. Remember that? When I gave you the example in the last class, H2SO4 and HNO3. Okay, so it's very strong acid. You can see its pH is very low. Now let's see how to define this pH, how to understand this pH. You know that the ionic product of water after autoionization is equal to 1.0 times 10 raised to power minus 14, right? Now, what can be the maximum value of hydronium? So I'm taking it in form of exponential. 10 raised to power 0. If hydronium is 10 raised to power 0, how much is OH minus? 10 raised to power minus 14. Now you can start decreasing your hydronium. Make it as 10 raised to power minus 1. Hydroxide will be minus 13. Make this one as minus 5. Hydroxide will be minus mhm, 9. Yes, minus 9. Make this one as minus 8. This will be minus 6. Make this one as 10 raised to a minus 12. This is 10 raised to a minus 2. Make this one as 10 raised to a minus 14. What is this value? This one? Yes. So we are going to define it between this 0, when the hydronium is 0, This is hydronium 0, 10 raised to power 0, to this one. This is hydroxide. So the pH scale will be between 0, this 0, and you can see this value 14, 0 to 14. This is pH scale. And pOH scale will be also 0 to 14, this 0 for the pOH. But what is the meaning of pH and pOH? pH is defined as, so I'm writing here to give you a good understanding of pH, pOH, pK, all these things. So what is a pH? This small p means log, negative log. Small p means negative log. When I say pH, then it is negative log of H plus. When I say pOH, then it is p means negative log. And after that, whatever is there, negative log of, yes, now start typing here, OH minus when I say this. See, p means negative log. If I say pKw, Kw is not a concentration, so don't put concentration there. So what is the meaning of this? Negative log of Kw. If I say pKa, negative log of Ka. If I say pKb, negative log of Kb. We are going to work with all these things, right? So you are going to, log is base 10 only. So all the exponentials can be taken care there, all these exponential. So generally, most of the concentrations of acids which are around us, it falls in the range of 0 to 14. This is the range of acids and bases which common people are using. So all of them are defined in that. Now let's try to understand. What's the meaning of 10 raised to power 0? So first, pH is negative log of concentration of H plus. Can you tell me the pH of solution 1? You plug in this 10 raised to power 0. Log of 1 is log 1. Yeah, 10 raised to power 0 is 1. So solution 1. What's the pH of solution 1? 0. Log 1 is 0. Right. Okay. Can you work out the pOH of solution 1? pOH. This is OH minus. Negative log of OH minus, which is negative log of 10 raised to power minus 14. You know this rule in logarithm, that log a raised to power 10 raised to power x is nothing but x log 10. And log 10 is 1. It's just x. Yes, just 14. Yes. Because this minus and this minus will become plus. So it is plus 40. Just 40. Can you tell me what's the value of pH plus pOH in solution 1? Isn't it 0 plus 14? So children, this is an equation for you. These are the equations which we are going to use. pH is this, pOH is this, pH plus pOH for every solution is 14. The sum is 14. You can check in solution 2. We are working with solution 2 now. Check solution 2. What's the pH? And what's the pOH? And what's the sum of pH plus pOH? Solution 2. pH is, take negative log of this number, pH is 1. pOH is, take negative log of this number, is 13. The sum is 14. So this solution, now let's decide one more thing. As we are going from solution 1 to 2, then we'll go to 3, then we'll go to 4, 5, 6. As we keep going from one solution to 6 solution, the pH is changing. But which one is more acidic, solution 1 or solution 2? Answer this question very carefully. Which one is more acidic, 1 or 2? Solution 1 is more acidic, Lisa, very good. But what is the pH of solution 1? 0. What is the pH of solution 2? 1. So can I say as pH is increasing, solution is becoming less acidic and more basic? Who is saying? Aditi? Solution, oh, you're saying solution 1 is more acidic. Okay, good. So can I say that more is the pH, more high pH means less acidity, more basic. Low pH means more acidic, less basic. Let's see solution 3. Solution 3. What's the pH? 3 is here. pH is 5. What's the pOH? pOH is 9. This solution is less acidic than 1 and 2. And check what is happening to pOH. Here the pOH is 14. Solution is very less basic. Solution 1 is less basic, more acidic. Solution 2, pOH is 13. pOH is decreasing. It's becoming slightly more basic, less acidic. Here it's more less acidic. It's slightly more basic than 1 and 2. It's not pH, pOH. These are pOH, right? pOH scale is exactly opposite of pH scale, right? Okay, let's have a look at this solution 4. Now you can see that when you add them, you are still getting 14. The sum is 14. Solution 4. pH is, pOH is, solution 4. 4 is this, pH is 8, pOH is 6, sum is again 14. But this solution is now basic because here the concentration of OH minus, can you see this, is more than that of H plus. So this solution is acidic. Oh, sorry, not acidic, basic. And this solution 1, 2, 3, they all were acidic. And solution 4 is basic. Solution 5, what's the pH? pH is 12. pOH is 2. If you know pH, you can calculate pOH by using this equation, the equation which I gave you here. This equation. If you know pH, you can calculate pOH. If you know pOH, you can calculate pH, right? So please write down these equation pH, pOH, pH plus pOH is 14. And of course, these are also very important, all of them. So as the pH, as I go to solution 6, last solution, solution 6, let's decide about it. Solution 6. What's the pH for solution 6? 14. And what's the pOH? 0. This is most basic. Lisa, here comes your solution, the one you are talking about. This is most basic. It has a very high concentration of OH minus, very low concentration of H plus. Right? So this is the one which is most basic. And this is the one, the top one here. This one. What is it? It is most acidic, right? So you can see that this pH scale is much better than using these exponentials. If the pH is very high, basic. If the pH is very low, acidic. If I give you two different pH, you can easily compare their acidity, right? And of course, these equations, we are going to work more on it. Now I'm giving you the pH of water, pure water. So let's work with pure water. H2O reacting with another H2O, giving you, can you complete the equation, children? Ionic product of water, autoionization equation. Can you complete it? Because the question which I'm going to teach you, I have seen this question in pre-response. Water. Yes, very good. H3O plus, aqueous plus OH minus, aqueous, and this is liquid, and this is also liquid, right? Now, what is Kw? Is the product of these two. Okay, if I have started with pure water, this is initial, change, equilibrium. Initially, there is some amount of liquid because this is not the part of Kw. You remember Ksp? We were doing the same thing, solids, liquids. So I'm just placing a dash here, dash here. Initially, before dissociation, how much hydronium? Before, initially, before dissociation of water, how much hydronium? X, 0, sorry, not X, 0. How much OH minus? 0. Before dissociation. Now let's say X amount has dissociated. How much hydronium will form? Plus X, that is formed. How much OH minus? Plus X. I'm just placing dash for them because they are not a part of my equilibrium. There is no need of showing it. Equilibrium. How much hydronium? X. How much OH minus? X. Now, what is Kw, children? Ionic product of water. Concentration of hydronium times concentration of OH minus at equilibrium at this point. But this is pure water, pure water. And what is the concentration of hydronium in pure water? X. OH minus X. What's the value? At 25 degrees Celsius? This one, right? So what is X? What is X? Right? Take the square root of this number because this is X squared. This one, X squared. So what is X? Square root of that. What's the value? Yes, Lisa, very good. 1.0 times 10 raised to power minus 7 molar. But what is it? What is this X? It is the hydronium ions concentration, which is equal to hydroxide ion concentration, which is equal to 1.0 times 10 raised to power minus 7 molar, right? So children, what's the pH? Negative log of this. If you remember the rule for logarithm, log A times B is log A plus log B. So if you use this rule here, what's the value of log 1? 0. What's the value of 10 is to minus 7? Negative log is 7, right? So pH is 7. pH is 7. So pH 7 means neutral on the pH scale. Above 7 pH, basic. OH minus is more. Below 7, acidic. Lesser pH, lesser pH, more closer to 0, more stronger acid. See, hydrochloric acid, right? So we are understanding this. Are we okay? How to calculate the pH of pure water? They will give you this question. Calculate the pH of pure water. So take autoionization of pure water. Make the rice table the way we were doing earlier and plug in these X and X here in the Kw. Take the value of Kw at 25 degrees Celsius. Get the value of X. That X is the concentration of hydronium and hydroxide. Take the pH. That's negative log of hydronium. And you are with the pH. What's the pOH? There are two ways. pH, pOH is 14 minus pH. This is one way. Or pOH is negative log of concentration of OH minus. Children, are we clear about it? Any questions? No? So let's do some questions. Before we start doing questions, I have a question. There is a solution A with a pH of 10. Solution B is with a pH of 5. Which one is more acidic? Which solution is more acidic? Ariba, what's your answer? Ariba. Yes, Azuni. Fine. Solution B. So, pH is high. High. It means concentration of H plus is low. Less acidic. So H plus is low. Which solution is more basic? A or B? A is more basic. If pH is high, then what happens to pOH? If you check the pOH here, in this, pOH is 5. In this, pOH is 10. If pH is high, pOH is low. If pOH is low, concentration of OH minus is high. Inverse. Yes, yes. It's 14. The sum is 14. So 4 and 9. Yes. Thanks for correcting me. Because the sum of pH plus pOH is 14. Who is this? Aditi. Very good. Yeah, Lisa. Thank you. You're understanding this, children? Ariba, you have taken it correctly now? Okay. Now we are going to do questions. Before we do the question, we have done few equations here. One is pH is negative logarithm of H plus ions. pOH is negative logarithm of OH minus ions, pH plus pOH is 14 from this scale, from this Kw of the water. We derived all these. But we did one more. We didn't. Oh, okay. I have not discussed one more equation. So that equation is, from this equation, mathematically, the concentration of H plus is 10 raised to power minus pH. This one, 10 raised to minus pH. Because log is base 10. So when you take the inverse of this function, when you take this H plus, when you isolate this H plus, you get this equation. Now you have to practice this equation. It will make many calculations very simple. Here from this, can I say concentration of OH minus is 10 raised to power minus pOH? Can I say that? So you have to practice these equations. Like if pK is given to you, what is pKa? Is negative log of Ka. pK is negative log of Ka. So what is Ka? Can you tell me? Can you type the equation here? What is Ka then? pKb is negative log of Kb. So what is Kb then? Ka is 10 raised to power minus pKa. pK, P. Where is P? Lisa, there is no P. Azuni, Lisa, P. pK, this value. The way we are saying here pH and pOH, right? And here Kb is, what is Kb? Negative, oh, Kb is 10 raised to power minus pKb. You know that, what is pKw, children? What is pKw? Okay, Lisa. What is pKw? Negative log of Kw. And you know the value of Kw? Plug in that value. So what is pKw? 14, very good. Then what is Kw, children? Kw. Isn't it 10 raised to power minus pKw? Plug in this 14. 10 raised to power minus 14. And actually it is this the value. Can you see? So these equations are equally important, very important. This one. Now we are ready for the questions. I hope you have written all the equations. Moving to the questions. Okay, here comes the very first question, which is based on Lee-Chatelier principle. They're asking, is the autoionization of water is exothermic or endothermic? Let's write on the equation. H2O liquid, H2O liquid is setting up an equilibrium, H3O plus aqueous and OH minus aqueous. That's the equation. Now, if it is endothermic, heat will be on this side. Endo, if it is endo. If it is exothermic, heat is on this side. And if you remember, temperature is the only one, temperature is the only one which can change the value of Kw. This we did in unit 7 also. Now, as you are increasing the temperature, stay with me, listen to my every sentence carefully. Can you see temperature is increasing? What is happening to the Kw value? And you already know that Kw is concentration of H3O plus times concentration of OH minus. Yeah. Aslisha, you are not answering anything. Ariba is increasing. If it is increasing, in which direction the equilibrium is shifting? Because Kw is this. In which direction the equilibrium is shifting? Yes, here, in which direction it is shifting? If it is increasing, Kw is increasing. If it is increasing, in which direction the equilibrium is shifting? To the left or to the right? Shifting to the right. Very good. Perfect, Azuni. Perfect. Right. And you remember, if you increase temperature, equilibrium shifts away from heat. Equilibrium will move away from heat because you are increasing temperature. So according to Lee Chatterley principle, it will try to nullify this effect and it will move away from heat. So on which direction, Ariba, I should write down heat? In which direction, the left or right? The equilibrium is moving away from heat. So heat is on the reactant side or product side? Azuni. It is on the reactant side. Very good, Aditi. If it is on the reactant side, then this autoionization of water is endothermic, exothermic. Mhm. Is on the reactant side. Azuni is gaining heat or losing heat? Reactant side. Heat is gained or lost? Heat is gained. So it is endo, Azuni. Endothermic. Okay. Now this question I have already done with you at 25 degrees Celsius. We are going to repeat the same thing, exactly same thing, the way I did. You remember XX, but this time you will take the Kw at this value, this value. You're not going to take this. Can you see? Kw value which we are using is here. But they're asking at 50 degrees Celsius. So we are going to do the same thing as we did earlier. Can you help me, children? It's just the repetition of the same question. Keep telling me, I'll write it for you. This is reaction, initial, change, equilibrium. Yes, this is liquid. Liquid. What should I do here? Dash, 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 right? Initially, how much hydronium? 0. How much OH minus? 0. Let's say X amount dissociated, X. How much hydronium formed? Plus X. How much OH minus formed? Plus X. How much is here? X and X. This plus this. X and X, right? What is Kw? Concentration of hydronium times concentration of OH minus. What is it? X squared is equal to 1.00 times minus O. We are not working at 25. We are working at 50 degrees Celsius. So don't use this value of Kw. You will use 5.47 times 10 raised to power minus 14. Oh, no, no, no. What are you doing, Asuni? Okay. The value is given here, right? You are going to pick up this. Kw value at 50. You cannot say temperature is doubled and Kw is doubled. Oh, it's not like that, right? Okay. Now get the value of X. And then you will come to know the concentration of hydronium plus and which is equal to the concentration of OH minus. See, they are equal because this is pure water. Pure water. Do you think at 50 degrees Celsius, water is acidic, basic, or neutral? Okay, Aditi is giving me the value. Thank you, Aditi. 2.7 times 10 raised to the power minus 7 molar. So at 50 degrees Celsius, when the Kw is higher than what is it at 25 degrees Celsius, is the water becoming more acidic, more basic, or is still neutral? Children, please check this value. Just take the square root of this to get the value of X. Who else is doing calculation? Lisa, you're back. Can you do the calculation here? Okay, 2.3. Okay, good. Is this solution acidic, basic, or neutral? With this Kw value, is it acidic, basic, or neutral? Answer it. Azuni is saying neutral. What about rest of you? Aslesha? Neutral. Okay, good. Ariba? Is it acidic, basic, or neutral? It's neutral. Why? Because they are equal. So it doesn't matter if you raise the temperature, the neutrality of the water is not going to change. It will still be neutral. With more concentration of hydronium, there is more concentration of OH minus. Okay, going for the next question. Ready for this question? Remember, I gave you the equation that concentration of H plus is 10 raised to power minus pH. Concentration of OH minus is 10 raised to power minus pOH. I can use it here. So can you work out the pOH, children? What's the pOH? And then this equation, pH plus pOH is 14. Okay, pOH is 4.37. What's the H plus? 10 raised to power minus 9.63. Plug in as such and you'll get the answer. Molar. What's the OH minus? 10 raised to power minus 4.37 molar. If you plug in this and put enter, you'll get answer in scientific notation. Yeah, this is for OH minus. Correct, Lisa? Mm. H plus? Oh, okay, H plus. Yeah. OH minus will be somewhere around 3 or 4. This one. This is somewhere around 10. Okay, good. Is this solution acidic, basic, or neutral, children? Check just from the pH you decide. Above 7, basic. Below 7, acidic. Right? So it is basic. Everybody is saying basic? Okay, now let's do solution B. Start from here. OH minus is given. I think you can work out the pOH, right? From this concentration, let's work out the pOH. When you take negative log of this number, please start the number with parenthesis. If you don't do that, then it will take the negative log of this number only and close the parenthesis. Negative log parenthesis start closed. pOH is 5.4. What's the pH then? What's the pH? 6.6. Is it? No. 8.6, right? Yeah, 8.6. What's the H plus concentration? 10 raised to power minus 8.6. Is this solution acidic, basic, or neutral? Decide from the pH. It's basic. Yes. Let's do solution C. The ideal way is again the same thing. H plus is given. Get the pH. pH is 1.6. Who is doing these questions very fast? Lisa and Azuni are working very fast with the mathematics. Aditi, good. All of you, please answer this question very fast because they are simple. We are going to do more complicated questions very soon. What's the pOH? What's the pOH? 12.4. What's the OH minus concentration? 10 raised to power minus 12.4, which you can plug in your calculator. Very good. Is this solution acidic, basic, or neutral? Just focus on pH. It is acidic. Very good. Let's do the last one. Solution D. pOH is given. Can you work out the pH? What's the pH? 12.79. What's the H plus ions? 10 raised to power minus 12.79. OH minus 10 raised to power minus 1.22. Is this solution acidic or basic? Oh, is it 7, 8? Yeah, it is 7, 8. Okay, thank you. Is this solution acidic or basic? It is basic. Very good. Now, check solution A, B, C, D. Which solution is most basic? Which solution is most basic? Solution D with the highest pH. And which solution is most acidic? Solution C, yes. We are good with this, children? Okay, before we do other questions, I want to tell you about the SIGFIG rule, significant figures rule, on the pH scale. In the pH scale, if like this number has how many SIGFIG? If I ask you how many SIGFIGs are here on this number? This number? Yes? Yeah, 2. Now the pH number, when you calculate the pH or pOH, that number should also have 2 significant figures. Can you tell me the pOH here? What's the pOH? Take negative log of this. There's an easy way of doing it. 6 minus log 3.9. You can do like this also. You'll get the same answer. So you're saying pOH is 5.4 exactly? Is there any other number? 5.4089. Okay, let's take it completely. Now, children, understand. This 10 raised to power minus 6, which finally has become 5, is not the part of significant figures. Any number before decimal in the pH or pOH or pKa before decimal, any number 1, 2, 3, you are not going to consider for sig fig. This number has 2 sig fig. I want to write pOH in 2 sig fig. I will not consider 5 because it has come from the exponentials, this exponential. I'll consider from here. So the answer is 4.5.41. That's the answer. Is it okay? You're understanding this? So if some number is written, some concentration of H plus given to you as 2.50 times 10 raised to power minus 2 molar. You take the negative log of this to get the pH. So an easy method, I'm giving you a trick here. 10 raised to minus 2 is 2 in pH. And then you are left with only minus log 2.50. Whether you use this method or you can take the negative log of this complete, you will get the same answer. And answer is given by Azuni. But how many significant figures in my this part? How many significant figures? How much you are getting, Azuni? Oh, no, you didn't give me the answer. Sorry. What's the answer for this one? Chat messages are very small. Sometimes I cannot see them properly. No, give me full answer, Azuni. 2 minus log 2.50. What's the full answer? I'm looking up for my calculator. 1.602? Okay. 1.602. Now this number has how many sig fig? This is the pH value. Do not consider this one. This number has 3 sig fig. So that's the right way. Yes, Lisa. I hope this is clear to all of you. Now, when you're going to answer the questions, take care of sig fig. The numbers before decimal in the pH and pOH values are not sig fig. They are exponentials. Ready? This question. After the decimal, the significant figure starts after the decimal, not before decimal. Like if I give you pH as 12.10, how many sig fig? This is the pH. If I'm saying this is the pH, how many significant figures? Mhm. How many? Two. These two. Yes. Do not count this 12. Okay, so take care of that. Let's do this question. The pH of a sample of gastric juice, pH is given. How many significant figures in this pH? 1. What's the concentration? What's the pOH? 11.9? Yes, 11.9. What's the concentration of H plus? 10 raised to power minus 2.1 molar. Now get the answer in one significant figure. Calculate, plug in your calculator and get the answer in one significant figure. Mhm. Yes. For this one, get the concentration of H plus. This pH has one significant figures. So I'm getting in scientific notation as 8 times 10 raised to power 1, 2, 3 minus 3. Are you getting the same? Yeah, you're also correct, Azuni. There's no need of saying sorry. It's correct. It's correct. You have given me answer in one sig fig. Okay, and OH minus 10 raised to power minus 11.9. One significant figure, Lisa. You are giving me 2. For the OH minus, you are giving me 2 sig fig. So answer is 1.0 times 10 raised to minus 12 molar. No, no, don't take 1.3. Take only 1. Oh, there is no point 0. Sorry, I am also writing 2 sig fig. So you can say drop this 3.3. No, no, that's for the pH and pOH values, Lisa. pH and pOH value. The answer which you are giving me is of the concentration of OH minus. You are giving me this concentration, right? If it is pH, pOH values, can you see there's no unit here? If it is pH, pOH value, then after decimal, sig fig starts. But for others, the rule is same as we were doing earlier. Do we figure out H plus? No. The pH was given as 2.1 and we said H plus. We are using this equation 10 raised to power minus pH. Yes, this equation. We say that is anti-log. We are taking anti-logarithm of the values. Inverse function. So rather than going for that, we are using this equation. Yes. Okay. So remember I gave you all these equations, Aditi? Okay, very good. Ready for more questions, children? Okay, before we start more questions, let's talk about another important. Okay, Aslisha. Let's talk about acids, bases, conjugate acids and bases. Okay. So we remember that we spent so much time on conjugate acids and bases. If the acid is Ha, is going to set up an equilibrium to give H plus aqueous and A minus aqueous, right? What is the conjugate? If this is the acid, what is the conjugate base? What is the conjugate base? A minus. This H plus, we are working in water, right? Aqueous means in water. So this H plus can be written as H3O plus, right? If I write water here, then it is H3O plus. Can you write down the dissociation of this A minus, which is the conjugate base in water? Can you complete the equation? You know that is the base. Is behaving like a base in water. So what are the products? What a base can do? Bronzed acid with base definition. Yeah, very good, Lisa. Very good, Lisa. Perfect. Ha plus OH minus. Perfect. Right? Okay. Now, can you write down Ka? Because this is acid dissociation. So let's write down Ka expression for the above equation. Do not include liquid water. So what is it? H3O plus times A minus over Ha. Normal equilibrium constant. concentration of the products divided by the concentration of the reactant. Liquid water not included. And because this is the dissociation of the acid, so I'm saying Ka. A means acid. Now let's write down Kb. Can you write down Kb here? This is liquid. All these are aqueous in water. What is Kb? Yes, children, write down Kb expression. Base dissociation constant. Mhm. Waiting for the answer. Very good, Azuni. Perfect answer. Kb is concentration of Ha times concentration of OH minus over concentration of A minus. That is Kb. Now, let's multiply Ka with Kb. Multiply it. When you multiply Ka with Kb, what are you getting? Multiply. Don't you think Ha cancelled? If you want, I can write it again for you. Ka is H3O plus times A minus. Yes, very good, Azuni. Over Ha. And Kb is Ha times OH minus over A minus. Cancel the things. See what is left. What is left, children? Lisa, do you know this? Lisa and Aditi, do you know what you are writing? What is it called as? What is it called as? What they are writing is this. What's the other name for this? Ionic product of water. That is Kw, which is 1.0 times 10 raised to power minus 14 at 25 degrees Celsius. Can I say that Ka times Kb is Kw? Can I say that, children? Now you do one thing. This is another equation. Remember this equation. Kw is this value. Remember this equation. So in some questions, Ka will be given to you. I will be using it in titrations. This equation will be using. Then if you know Ka, then you can calculate Kb of the conjugate. Right? Okay. If I take negative log of this, negative log, then it is negative log of Ka minus, actually multiplication means plus, and then this is minus log, so plus minus log of Kb. Agreed? We know this rule from our zero unit. We know that log A times B is log A plus log B. I'm using this rule, this one here. What is it? What is this? Negative log is P, small p, pKa. What is this? pKb. You're getting it? And this pKa plus pKb is negative log of Kw. And what is negative log of Kw? pKw. And we know its value. You take negative log of this, you'll get 14. More equations, children. pKa, pKb, pKw, pKa plus pKb is 14. pH plus pOH is 14. We are okay with this? Now I'm going to compare the values. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . Let's see the relationship between them. Okay. Before we start anything, I want to discuss pK and pKb more. There is a solution A. It's an acid. Ka value for this acid is 1.0 times 10 raised to power minus 5. What is this pKa? What is the pK? What's the pKa? Yes, 5. There is another solution B. Its pKa value is 1.0 times 10 raised to power minus 6. What's the pKa? 6. Very good, Azuni. Perfect. Now, which solution is more acidic? You remember we did comparison of strength of the acid. Which solution is more acidic, more stronger acid? A or B? Why? Yes, you're right, Azuni. Lisa, you're right. But why? Or she's saying pK value is less. Or can you tell me in terms of Ka? Tell me in terms of Ka, Lisa. Aditi, try to answer. Ariba, you're not answering anything. Again, don't make me call your name, please. Ka value is higher. Yes. So can I say, if Ka value is high, pKa is low? And you know that pKa plus pKb is 14 fixed. You know this equation, right? If pKa is low, then what happens to pKb? Is high. Then what happens to Kb? Low. If Ka is high, then you are saying it's a strong acid. That's what you said, right? If an acid is strong, then what happens to the concentration of H plus? A strong acid, concentration of H plus. Aditi? Yes, Lesha? You're not answering? No, 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 no. No. If Ka is high, then it's a strong acid or weak acid, Azuni? Ka, acid dissociation constant is high. Strong what? Acid or base? Strong what, Aditi? Oh dear. What about rest of you? Ka represents, what this A represents? Yeah, it represents acid. If Ka is high, then it means it's a strong acid. So concentration of H plus will be more, right? So what happens to pH? If concentration of H plus is more, pH is less. If concentration of H plus is more, what happens to the concentration of OH minus? You know, H plus times OH minus Kw. Low. If concentration of OH minus is low, what happens to pOH? See how they are related to each other. They are connected to each other. So in a solution, I can talk about Ka, I can talk about Kb, pKa, pKb, pH, pOH, H plus, OH minus, everything. You're understanding this? Lisa, is it okay? Ready for one question now? Okay, fine. It's a strong base. Now let's decide everything. The solution is a strong base. So concentration of OH minus. Yes. High, low. A strong base. Concentration of OH minus is high or low? I won't answer from all of you. Ariba, Aslisha, answer it. Aslisha, you're there? Strong base means high concentration of OH minus. High. Children, do not miss the class, not even 5 or 10 minutes. Because if you miss something, you're going to miss a lot then. You will miss everything after that. So come prepared for the class. You have to understand this. This is not for me. This is for you. If the concentration of OH minus is, if it is a strong base, concentration of OH minus is high. What happens to pOH? pOH. Low. Very good. If concentration of OH minus is high, what happens to the concentration of H plus? Low. What happens to pH? High. Yes. If it's a strong base, what happens to Kb value? Kb, the dissociation constant. Very good. It's high. What happens to pKb? pKb? Yes, low. What happens to Ka? If Kb is high, what happens to Ka? Low. What happens to pKa? Yes. Yes. Good. The way we define for strong base, exactly in the same way, you can make strong acid. I think the first example I gave was of strong acid. Are we clear about how they are related to each other? Okay, so please write down these things in your notebook and then analyze it very carefully. Write all the equation. I gave you so many equations. I defined pH. I defined pOH. Then we worked with pKa. We worked with pKb. Then we understood the equation pH plus pOH is 14. And we also understood the equation pKa plus pKb is 14. From all these definitions and these two equations, you can relate them, right? Now, going on the questions, more questions. Okay, now we are working with the pH of strong acids and strong bases. So what is a strong acid, Aditi? What do you mean by strong acid, Aslisha? You know, we discussed in the previous class strong acid, weak acid. H plus is very high. Is there any other word I can use for a strong acid? This is one of the strongest. I was defining it as a strong electrolyte. Remember? Yes, fully dissociated. Yes, Aditi and Aslesha, perfect. It's 100% dissociated. 100% means there is no undissociated form. This is finally zero. H plus and ClO4 minus in water. So this is the reaction. What is initial here? Before dissociation, 0.250 molar. Initial before dissociation, this is 0. But now there is no rise table because there is no equilibrium. Can you see that I have made only one single arrow? So when there is single arrow, just talk in terms of initial and final. No, we are not going to discuss any change. Finally, what is this? 0. And how much H plus? How much ClO4 minus? Right? What's the pH? Negative log of H plus ions concentration. That is negative log of this. Right? And that will be the answer. How many significant figures in the pH value? 3 after decimal. Can you work out the pH? What is 602? Is this the pH? This is the pH, Ajuni and Lisa? Okay. Yeah, 602 is perfectly all right. 0 point. It's very strong acid. Can you see? It's very close to 0, less than 1. pH between 0 to 1, very strong acid. Below 0, more stronger, fuming acids. We can have negative pH also. Like there is a acid 16 molar hydrochloric acid. What's the pH? It's a strong acid. It's 100% dissociated as H plus and Cl minus. So if I started with 16 molar, initially these are 0, finally this is 0. How much is the concentration of H plus? 16. Cl minus 16. What's the pH here, children? Can you work out the pH here? pH of 16 molar HCl. 16 molar is fuming hydrochloric acid. Fuming. Fuming means when you open the cap of the bottle, comes out in the form of fumes. It's a negative pH, which I think Lisa and Azuni are doing great mathematics here. What about rest of you? Slightly lazy? Ariba, Aslesha? See negative pH. Can I take one more significant figure here? Because the 16 means 2 sig fig. You are giving me 1 sig fig. After decimal 2. One more. 0? Okay. Good. You're understanding this question now? Okay. Can you work out the pH of HNO3? HNO3, nitric acid, strong acid. So, let's write on the reaction. HNO3, a very strong acid, 100% dissociated, right? This is the reaction, initial, final. 0.250 molar. This is 0, this is 0. Then, how much is this? 0. How much H plus? 0.250. How much nitrate? 0.250. What's the pH? Isn't it same? Yes. Now answer this question. This one. What are the major species present in the solution? Major species. Major species you can see only from the final condition. So can you tell me in this HClO4 solution, finally, what are the major species? Lisa? What is finally? H plus and ClO4 minus. Is there any HClO4? No. What else? One more thing is there. If you don't write, they will take away your marks. There's one more. Aqueous means water. These three are the major species in the solution. In this HClO4, can you work out the major species in HNO3 from here? Yes, please write on the major species from this final condition and from this aqueous word. Yes, all of you. Yes, Azuni, very good. So she's writing all three, H plus, yes, and water. Yes, very good, Aditi. Aslesha and Ariba, you're not again answering. Good, Aslesha, yes. Ariba, okay. Ready to move on? Let's see this question. This question is slightly tricky. Remember unit 4? When you mix two volumes, volume A plus volume B plus volume C, you're mixing volumes, then concentration changes. So remember this line. So when in a question you see the concentrations mentioned and you see that you are mixing 2-3 volumes, then recall this line. Mixing volume calculate new concentrations. Write down this line. Print it somewhere in your head. And when you're looking at the question in the examination and they are saying, we are mixing this, that, they are giving you 2-3 volumes mixing together, then it means all the concentrations will change. And we have to work with the new concentrations. We already know that concentration is moles over volume. Now I will take the new volume, but moles will remain the same because I'm mixing volume like 50 ml of this HBr mixed with 150 ml of this HI. I'm mixing 150 with 50. That will not change the moles of HI or the moles of HBr. They will not change. But only volume will change, right? So let's see how to do this question based on mixing volumes. Okay. What's the V total? Total volume, finally. V total. Mm-hmm. Yes. V total, children. What's the total volume? 200 ml. Put a decimal and put a zero. Use that sig fig rule. You are adding these two numbers. You have to use the rule of decimal, right? So you put a decimal and then a zero here. Remember significant figures rule for addition and subtraction. You will express your number with minimum decimal places. And both the numbers have one decimal place. So it means final answer should also be with one decimal place, right? Okay, V total is this. Can you tell me the millimoles? You remember the word millimoles from unit 4? Millimoles. Molarity is millimoles over volume in milliliter. Millimoles, milliliter, same factor, 1,000. So you will get the same molarity as you are calculating by using moles over volume in liters. Whether you use moles with liters or you use millimoles with milliliter, the molarity value will be the same. So I'm going to use this equation, this one. So millimoles of HBr from this equation is unit 4. We did plenty of questions there. Molarity times volume in milliliter. And what's the molarity here of HBr? This 0.050 times 50.0. Go for 2 sig fig for the final answer. How much? How many millimoles of HBr? Mm-hmm. Millimoles. Asuni, what are you calculating? How come 10, Lisa? Are you adding them, Lisa? You're adding, right? And Azuni, what are you doing, girls? Aditi, Aslisha, help them. You are supposed to multiply a 0.05 with 50. Is Azuni right? Yeah, she's right. Oh, Aslisha, you are wrong. 2.5 millimoles of HBr. Can you calculate the millimoles of HI? Millimoles of HI? You are going to multiply 0.10 with 150.0. That's the volume. That's the molarity. And it is 15. Okay. And you will go for 2 sig fig. Yes, millimoles. Okay. HBr, HI. They are strong acids or weak acids? Remember, I gave you only 3 non-oxo strong acids. You remember the names? HI, HBr, HCl. Okay, good. Then, if they are strong, then HBr is going to dissociate completely into H plus and Br minus. Similarly, HI is going to dissociate completely as H plus and I minus. So if it is going to dissociate completely, then what is the final situation, initial final? In both the cases, initial HBr is, I'm working with millimoles, not with the concentration. Can you see that? Why? Because concentrations are going to change because we are mixing volume. So what happens to this 2.5 millimoles? It will become 0. And H plus is 2.5, 2.5, right? Same here. This is 15. This is 0 initially before dissociation. After dissociation, it's a strong acid. 0, 15, 15. What's the concentration of H plus? Concentration of H plus is total millimoles over total volume in milliliter. And what are the total millimoles? Anyone? Because you have mixed HBr with HI. So the total millimoles are 2.5 plus 15. Yeah, 17.5. What's the total volume? Total volume is? Remember we calculated here 200.0. These are millimoles. So I'm working with milliliter. What's the answer? What is the answer? Go for three significant figures in your answer. Yes. What are you giving me? The molarity or millimoles? Lisa, what are you calculating? Molarity. Yes. Yes, yes. Very good. 0.0875 molar. This is the concentration of H plus. Are they asking concentration of H plus? Yes. And the pH. What's the pH? pH is negative log of concentration of H plus. And the value of H plus is this. Negative log 0.0875. And go for three significant figures for the pH, means after decimal. How much is the pH? 1 point something? Yeah, 1.058. Perfect. That's the answer. So children, this question is telling you, these type of questions, though we didn't calculate pH over there, but these type of questions we did in unit 4. We were calculating the concentration of all ions in the solution. In this part, I just calculated H plus because we were aiming for H plus and pH only. But in the unit 4, we were calculating the other ions concentration also, like Br minus, I minus, like this. So when you are mixing volumes, then calculate the moles or millimoles and divide it by total volume to know the new concentration. Remember this line. Write it down, put a star. Unit 4 is based on it. Even this unit, when you are going to do titrations, you are mixing two volumes. Acid is mixed with base. Volume is changing. I'm going to clear it. Okay. Ready for this question, children? How to prepare a solution with pH 1.50. The volume of the solution is 1600 ml from 12 molar HCl. This question, if you remember the dilution law, unit 4, dilution law. Yes. What is the dilution law in unit 4? Yes, Aditi. Aditi, very good. M1 V1 equals to M2 V2. Dilution means you are adding water. So the moles before dilution and the moles. These are the moles, right? And these are also moles. What is mole? Mole is molarity times volume in liters. So you can use this dilution law here. But for that, I need to know the molarities and volumes if I want to use this dilution law. Now, very carefully understand this question, and if you have questions, you can ask. From this question, it appears that I have to make a solution with a volume of 600 ml, right? So let's say this volume is V1, which is 1600 ml. And the pH of that solution 1, is 1.50. It means I know the molarity of the acid. What type of acid is this? It's a strong acid. So I will calculate the H plus. What's the H plus? Which is also equal to the concentration of HCl. Do you agree with this? These two have the same concentration. It's a strong acid, fully dissociated. Is 10 raised to power minus pH, right? How much is this? 10 raised to power minus 1.50. How much is that? Calculate this molarity. And this is M1 is 0.032 molar. Perfect. Sig are also perfect. Very good. Is this answer correct, children? Aditi, Azuni is saying that M1 is this. Ariba, check this answer. Anyone checking? Okay, good. Fine. So I know M1 and V1. M1 is 1600. Oh, sorry. That is V1, right? M1 is this value 0.032 molar. V1 is 1600. I'm not converting this into liters because if I take V1 in milliliter, I'll get V2 in milliliter is equal to M2. What is M2? 12. And I'll calculate the V2. The volume of very concentrated solution. I'll calculate that. How much is that? 0.032 1600 over 12 is 4.22. I have to take only two significant figures. Azuni, two significant 4.2 ml. Is this answer correct? Lisa, are you getting the same? Aditi, Lisa, Ariba. Yeah, okay, good. Now the question is not done. They are saying how you're going to make the solution. How would you prepare 1600 ml from this 12 molar HCl? Now let's see how to prepare. I will take 4.2 ml in a burette. Oh, not burette, sorry. In a graduated cylinder. You know the meaning of graduated cylinder? It's like this. The long cylinder type. It has marks on it. Like this. Right? Small volumes like 4.2. I cannot use a pipette here, pipette or pipette, because pipettes have fixed volumes, 5 ml, 10 ml, like this. It is 4.2. So you can use a graduated cylinder. Then I'm going to take a volumetric flask. If you remember, we were discussing how to make solutions in Unit 4, volumetric flask, which is 1600 ml. Means if I fill it up to here, then it means it's total 1600 ml. Now I'm going to add water. I'm not adding acid, I'm adding water. Let's say I added water up to this much. You can take anything up to here, like this. Now, in this water, I'm going to add this 4.2 ml acid drop by drop. Acid. How much? 4.2 ml. Why drop by drop? Otherwise, heat will be generated because when you are adding such a strong acid, remember I told you that this is very strong concentration, negative pH. You calculate the pH is negative. So you add this acid drop by drop into this water so that whatever heat generated will be taken by water and the solution will not jump out. Otherwise, If you add water into acid, solution will jump out. So always remember, concentrated solutions, whenever you are handling any concentrated solutions are added drop by drop, drop by drop in water. Don't do the reverse. If you do the reverse, then solution can bump out because so much heat is generated. If you add water into concentrated solution, the complete acid will jump out and it can cause injuries. That's why we keep adding this acid drop by drop and keep shaking the solution. Means you are holding it from here so you can keep moving it in circular motions, right? Once you have done that, now you can add water, more water, more water, and come up to this level, and stop adding further. Now shake it properly and close it. Now this is your solution which has a pH of 1.50, this pH. Is it okay? So here, this thing we have done in unit 4 as dilution law. Also we did in unit 4 how to make solutions. And I discussed all these things there also. But here right now we have one additional point, that is pH. We didn't do pH in the unit 4. Okay, ready for next? This question, as I said, unit 3, we have done plenty of them, Aditi. Unit 4, sorry, not 3. We have done plenty of such dilution questions in unit 4. Can you check once from there? Let me see if I have more. In case I don't have more, then we can do some during review classes, or you can watch some old videos, unit 4 videos. Can you see this question, children? These are bases or acids? What are these? Bases. These bases are strong or weak? Aditi, you are giving me direct messages. Please select general message for all. Yeah, no problem. These are strong. We remember all the strong bases, children? First group hydroxides, including barium and calcium. Rest all are weak. Just memorize this line. So what is OH minus and pH of this solution? If it is a strong base means same story. It's 100% dissociated, right? K plus plus OH minus. What's the initial amount of KO? 0.015. K plus. What's the final amount of KOH? It's 100% dissociated. K plus, OH minus. They're asking pH. So they're asking concentration of OH minus. So concentration of OH minus is 0.015 molar. What's the pOH then? Negative log of 0.015. What's the pH then? 14 minus pOH. Agreed? So you know everything. What's the pOH, children? How much? You calculated? It should be 1 point something. Yeah. Go for 2 sig fig after decimal, 1.82. So what's the pH? Is it 12 point something? Yeah, 12.18. You're understanding this? Okay. Now let's see this one, B part. Barium hydroxide, BaOH twice. Strong base, 100% dissociated. Okay, children, this time I'm not going to speak much. You people are going to tell me what values I have to plug in here. Can you see this is 2OH, right? So I place 2 here. It's 100% dissociated. It's a strong base. What's the concentration given? 0.015 molar initial. How much barium 2 plus? How much this? Final. How much barium hydroxide? How much barium 2 plus? How much OH minus? How much OH minus? Very good. Very good. Double of this. Very good. So what's the concentration of OH minus here? 0.03 molar. Yes, molar, right? So what's the pOH? pOH. Negative log of 0.03. Correct? And what's the pH? 14 minus. Oh, you have to give me this answer in two significant figure. You know, 0.030. So 14 minus 0.030. So answer is 1.52 is what? So 12.5. Oh, okay, that's the pOH. Okay, fine. Yeah, sorry. You're right. I have to take the pOH here. And pH is 12.48. Is it correct? 12.48? Like Azuni gave me 12.50. Okay, it is correct. Okay, good. Are you getting this? 12.48 is quite high pH. High pH means very basic. Of course, it's a base, strong base. So generally all the strong bases, even with very low concentration, this concentration is not very high. Their pH are around 12, 13 like this. pH is above 10 if it is a strong base. Even at very low concentration, it is above 10, right? If it is a weak base, pH will be closer to 10. Okay. So children, I want you to do more questions, but I'll do these questions tomorrow. Please join at the right time. Tomorrow we'll work with the weak acids and weak bases. We'll make the rice table. Plenty of questions, questions and questions. Because rest of the things you know. There was something new like pH, pOH, pK, pKb that I discussed with you today. So whatever knowledge we were in need of doing these questions that we have done today, tomorrow we'll be discussing plenty of questions. Okay, so I want you to come prepared and join the class at the right time so that we can finish it before ending the class. We can finish whatever we have decided. So see you tomorrow at the same time, right? Okay, if you have any question, you can stay back. Bye.